Hi, my name is Mike Thompson. I'm with the OpenHW Foundation. We're presenting today a poster session that was done by our colleagues at Thales DIS to improve the performance of the CVA6. This is an open source RISC-V processor that's curated by the OpenHW group. The CVA6, when they started, was running at 3.1 CoreMarks per megahertz, and the idea was, how do we improve this performance? The most obvious thing to do is to start modifying the RTL, maybe add another execution pipeline or something like this, but that is going to be fraught and is going to produce very bad results. You'll probably break things more than you'll fix things. So the approach taken by CoM at Thales was to build a performance model, and to keep it as simple as possible. It was written in Python. It's not a cycle-accurate model, but it models the aspects that you need to model in order to understand the performance of the pipeline. So it would model the instruction queue, the scoreboard, and the retirement unit. And once they developed that model, they could do things like add additional execution units or additional commit units, and they could use their performance model to measure what the expected maximum performance would be of the RTL should they make those modifications. What was quickly, if you zoom in on this, what you can quickly see is the first benefit comes quickly, and then after that you get into a situation of diminishing returns. So if you add a second issue, you get a nice bump in performance. If you add a second commit stage, you get a nice bump in performance. If you start adding additional ones, the bumps become less and less. So the real sweet spot seemed to be adding a second execution pipeline to the core. This graphic illustrates that. You see that there's some code that was reshaped, some code that was modified, and some code that was duplicated. And this work on the RTL was guided by this work on the performance model. And you see that they were able to get pretty much exactly the same performance improvement in the RTL that they were able to model in the high-level model. So this is a demonstration of two things: how to improve the performance of a core that already exists, and how to use a high-level, non-cycle accurate abstract model to guide that work. And very happy to say that this has been successfully deployed. It's now part of the CVA6. So the CVA6 started its life as a single issue pipeline and has now been updated to be a dual issue pipeline, giving much better performance than before.